Hi everyone, and welcome back to a new video about IB Math. In today's lesson, we'll be explaining the double angle identities for the sine and the cosine functions, which is a topic in the IB Math AA standard level and high level. Now, the reason I'm explaining this is because I really see many students apply them in the wrong way when they need them in an exercise in their IB Math exams or tests. So in this video, I will show you how to apply them correctly, how to understand them better, and after that, we'll do a good example that needs double angle identities. So here, as you see, as they are given in the IB Math formula booklet. Here we have the formula for the sine and three equivalent formulas for, or identities, for the cosine. So here, as you see, we have sine 2 theta. This is the angle theta. By the way, these identities apply the same in degrees or radians. Sine 2 theta is equal to 2 multiplied by sine 1 theta, which is theta, and then multiplied by cosine theta. And here, as you see, the cosine identities. Now, to apply them correctly, you need to understand two things. First, whatever angle you have here on the left, it will be double of the angle that you have on the right. That's why we call them double angle identities. So for example, if you have here, let's say for example, 10x, then here it will be 5x. Half of 10x will be 5x. If you have here, let's say 80 degrees, then here it will be 40 degrees. Half of 80 will be 40. The second thing you need to understand is that this 2 has nothing to do with this 2. This 2 here is fixed. It's always 2. It's not a 2 because this is 2. No. Not only this, or even here the same way, these are fixed 2's. They never change, even if this one here changed from 2 to any other number. Now to clarify, we'll do some examples now. By the way, the cosine identities work in the same exact way. So now here, we'll have the first example. Let's say we have here sine 10x. The angle is 10x. It's equal to, I'll apply this. First, as you see, we have 2. So I'll start with a 2, not a 10 because I have 10 here. No. Then, what's half of 10x? It will be 5x. That's why I write here sine 5x, then multiplied by cosine 5x, and that's it. As you see, 10x is double of the 5x here. Another example. Sine 70 degrees will be, start with a 2 also. Half of 70 degrees will be 35. So I will write now sine 35 degrees and then multiplied by cosine 35. Now another example in radians, this time to illustrate the cosine, which is exactly in the same way. Let's say that I have an angle like 2 pi over 3 radians, which is, by the way, equivalent to 120 degrees. Here, as you see, 2 theta is equal to 2 pi over 3. So 1 theta, or half of 2 pi over 3, will be 1 pi over 3, which is just pi over 3. That's why I will apply these identities, but theta will be replaced by pi over 3. First, if I apply this, it's cosine squared pi over 3 minus sine squared pi over 3. Or if I apply this, it will be 2 cosine squared pi over 3 minus sine minus 1. I'm applying this minus 1, and then if I do this, it will be 1 minus 2 sine squared pi over 3. Of course, if you calculate all of these and even this, you will see that they are the same. So someone might say, how do I know which one to use, this or this or this? Of course, that depends on the question that you're solving. So if you need to replace cosine by only sines, then you need this that has only sine. But if only cosines, then you need this. In some identities proving, you might need this. So to clarify that, we will do now this example here. So here, as you see, we have question 1, no calculator, paper 1. You're given that cosine theta is 1 out of 4, but you need to find cosine for theta. First, keep in mind, you cannot find the angle theta itself here, and you don't need to, because it's no calculator, and it's not a main angle from the unit circle that you can apply. That's why we'll use the double angle identities correctly now, but we have a trick here, as you see. Here we have a problem that we know cosine theta, but they need cosine 4 theta, not 2 theta. So that's why we'll apply the double angle identities twice. The first one will move from 4 theta to 2 theta, because half of 4 theta is 2 theta. This is how it works. And then from 2 theta to 1 theta. We cannot do it in one way, so we have to apply the double angle identities twice. So I will start with what they need here. Cosine 4 theta equals, look, I will apply this because I have only cosines here, So it will be 2 cosine squared, but be careful not to put 1 theta like this. No, here it will be 2 theta in my example, minus 1. Don't forget the minus 1 as it is. Why 2 theta? Because again, half of 4 theta will be 2 theta. But as you see in the question, we have cosine 1 theta, not 2 theta, which means I have to find cosine 2 theta as well. So cosine 2 theta, because we have 2 theta, then I will use this one as it is literally because it's 2 theta. So it will be 2 times, as you see, times cosine squared theta. By the way, cosine theta is 1 out of 4. So if you replace it here, you have 1 out of 4 squared and then minus 1. So 1 out of 4 squared minus 1. If you calculate these simply, they will be negative 7 over 8. So now I'll use it here. Here, as you see, we have 2. Then here, as you see, you have cosine 2 theta, then squared. Cosine 2 theta is negative 7 over 8. So I will do negative 7 over 8, but don't forget the square here. And then minus 1. If you calculate here simply, the final answer will be 17, as I got here, 17 divided by 32. So this is the final answer to our question here. I hope that you have enjoyed the video. Please hit the like button and consider subscribing to the channel. Thank you for watching.